If you require technical assistance, please type your question into the question pane located on the right side of your screen and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to the speaker. You are able to zoom in on the presentation content by using the Zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will appear in your web browser. I'd like to take a moment to thank our presenting sponsors, Microsoft, Amazon Web Services, Hortonworks, and Redgate. In addition, I'd also like to thank the supporting sponsors for this event, Hewlett-Packard Enterprise, SQL Sentry, and SanDisk. The staging of 24 Hours of Past would not be possible without their generous support, and they are the reason this event is available free of charge. Make sure you explore everything else PASS has to offer for data professionals. You can join local user groups around the world, special interest groups, find free online resources through our Learning Center, and read up on the latest community news in the Connector newsletter. And now I'd like to take a moment to introduce the speaker of the hour, Robert Davis. Robert is a database engineer at Blue Mountain Capital Management. He is a former principal database architect at DB Best Technologies. He's a former principal DBA at Outer Wall Inc., a former senior product consultant with Adira Software, a former program manager for SQL Server Certified Master Program in Microsoft Learning, a former production DBA operations engineer at Microsoft. He is a certified master and a co-founder of the SQL Pass Security Virtual Chapter. Take it away, Robert.
Thank you, Elizabeth. So I'm going to be talking to you today about what I like to call a new paradigm for performance tuning in SQL Server 2016. So slow queries, who's got them? So I'm guessing pretty much everybody out there has to deal with these. Whether you're a developer or a DBA, at some point, all of us have to deal with slow queries. We also have to deal with things like inconsistent performance, queries that run good sometimes and doesn't run good at other times. One of the classic situations as a DBA that we get all the time is, hey, this ran slow at 2 a.m. last night. What happened at that time? And it's very difficult. Unless we got, some extensive monitoring in place, it's very difficult to figure out, what happened in the past. Because we can't just go and look at the server to see what was going on at that time. Another issue is we have query plans for the same query that keep changing. We may get a table scan one time and it runs slow. The next time we get a clustered index seek and it runs fast, and it can be very challenging to dig into those plans and try to figure out why it chooses one plan or another at different times. Fortunately for us, they've introduced some great tools for us for performance tuning in SQL Server 2016, and I'm going to talk about just two of those today. One is called the Query Store, and the other is called the Plan Compare tool. Now, specifically about the Query Store, it actively tracks query plans and query performance in your server as it's running. It identifies query plan regressions and performance inconsistencies for you, and it's also going to be kind of a replacement for the old process of using plan guides. And it's much simpler now when you have a query that has the plan keeps changing a lot, and sometimes it's good, sometimes it's bad. If you have a plan that will always be good, you can easily just, with a couple of clicks, force it, and it will always use that plan for that query. And if the plan stops performing well, because your data changes over time, the shape of the query will change over time, and so what is a great plan today may not be a great plan a week from now. So if you find that it does start performing badly, it's just as easily to unforce that query plan with just a couple clicks. It really is as simple as that. And the other tool I'm going to talk about is the Plan Compare tool. Now the Plan Compare tool allows you to compare plan properties side by side. Normally, if we want to compare two versions of a query, compare the plans, what we have to do is we create two different versions of the query, and usually I use like index hints or something to force one of the queries to perform in a specific way, and then I can perform some manual comparisons between the two. This tool actually does some stuff automatically for you. You can use an actual plan that you've just generated. You can use cache plans, and you can compare two of them in the window. You don't have to run the queries at the same time. I can save one of the plans and run a different version of the query and then compare those two, and it gives me the properties of the specific nodes I'm looking at side by side so that I can easily identify differences where there are differences. It also does identifies matching operations for you, so you can easily compare, find which nodes match up, because a lot of times the plans will be shaped completely different, and so if they're vastly different, it can be difficult to find out, okay, especially for a large plan, what nodes match up to which. So this does that for you and helps you identify those nodes that match up. And it is color-coded, so it makes it easier to identify those codes. And this screenshot is actually from an older version of the SSMS, so it'll look a little bit different when we do the demo, but it is still color-coded. And syncs the plans and the nodes you want to compare so that you can compare them in the graphical view in the properties boxes. And that's really all I'm going to go through the slide deck for today. I'm going to spend the rest of the time doing demo. So let's jump into that. So I'm running the RC3 of SQL Server 2016 on my laptop, and first thing I want to do is Query Store is disabled by default, and it is separate in each database. So you can enable it in each database. You can enable it in only one database or only the ones you care about. So it's very selective. It's not all or nothing. So for today, I'm only going to be concerned with one database. I'm going to turn it on in my AdventureWorks 2016 database. Now, in Object Explorer, when I expand the node for the database, I don't see anything right away. But if I look at the properties of the database, in the navigation, there's a new tab called Query Store. And you won't hear me talk positively about the GUI very often, but they actually gave us some really good tooling for the Query Store in the GUI for SQL 2016. Now, one thing to note is it does use disk space within that database, so you will need to consider that the amount of space you're storing performance data will be part of your database. By default, that space is very small, and you can very easily look at it. As you can see on here, it gives you some graphs showing you how much disk space it's using, so it's very easy to do. So the first thing I'd like to point out on the GUI here is the operation mode. It shows you actual versus requested, and there's a scenario where this is very important. Now, to enable it, I can just change operation mode to read-write. So read-write mode means that I can query the query store, and it is actively tracking queries and query plans in the store. Read-only mode means that I can still query the query store, it's still there, still available to look at the data, but it's no longer actively tracking any data. So the reason that it shows you actual versus requested is there are scenarios where the query store could stop collecting information and could transition to the read-only mode. So if I were to check read-write right now and click OK, then go back to this page in the GUI, we'll see that the actual mode is the same as the requested mode. So this is what we want to see. If, for example, your query store runs out of disk space, so as we can see here, query store retention, it's by default it's limited to using only 100 megabytes of space. If I fill that space up and it can no longer store any more data, won't get errors, and it won't cause queries to fail because it can't track them. Instead, what it will do is it will change the operation mode from read-write to read-only. So if you find that new information isn't showing up, this is one of the first things I would check. If you see that actual operation mode was read-write, or is read-only, and the requested mode is read-write, then it has transitioned to read-only because of some problem. Most likely the disk space, so that would be the first thing to look at. If you are out of space, there are some system procedures you can use to selectively clear out some data. You can also just write down here, if you decide, okay, I just want to get rid of all the old data, you can click this button to purge the query data and it'll dump all the old data. And you can change the requested mode back to read, write, and you're back in business. So most of the options you see in here are things that I'm probably, out of the box when I set this up in my production systems, I'm probably not going to mess with those. I'm just going to leave them at the default values. One thing I may change right out of the box is if I'm putting it on a very busy production server and I know it's going to generate a lot of capture data, I'm probably going to go ahead and bump up this max size to some larger value. So like right now I'm just going to set it to 1,000 megabytes, approximately a gig, not quite, but almost a gig. And in production, I'm probably not going to change the data flush interval, but it is in, in minutes. And for the purposes of this demo, I want to bump this up. I'm going to bump that up to 1 minute. And I'm also going to put the collection interval at 1 minute because, I'm going to be doing some stuff and I want to see the collected data fairly quickly here. So I'm bumping those up. But in production, I'm probably not going to bump those up right away. If I see that things are getting missed, I may bump those up in production after it's run for a while and I see that I need to. But just out of the box, I'm not going to change those in my production server. So now I've got it running, I've got it collecting data. If I refresh the database node here, we see now that there's a new node that appears on the database called Query Store. If we expand that node, we can see that they give us some views in here right out of the box that we can click on and see. And we can see I've already got some information in here. And if we see the queries down here, you can say, okay, clearly those are system processes running in the background. So I can see that information. I can see that there's already some information in there. I can tell what kind of information is giving me. If I click back on this one, we can see what that query plan for when that ran was. We can see over here, okay, here's the plan ID. If this query has had multiple plans, let's say if this ran again and it got a recompiled and got a different query plan, we would see a second dot over here, and from this view we could click on one of the dots to view the different plans. And then if we decided that, hey, this one plan is really good and much better than the other. I can then, to force that plan, just click on the one I want to force, and then just come right here and click force this plan, and then from that moment on, that query will always use that plan. And this is an analogous to the plan guides that we've been using for many years, except much easier. And then again, if it's not performing well or was questionable, I could always come over here and find that plan ID again and click unforce the plan. So very easy work. So let's go ahead and generate some activity to have a look at. So first thing I'm going to do is I'm going to make sure my demo environment is reset. Make sure we're doing some stuff with the cardinality estimator for this query to force it to generate different plans. So I'm going to make sure that trace flag is turned off for the first iteration. And so then I'm just going to run this query that I wrote, and as you can see, I'm using functions to compare different on the columns to compare them, and forcing it to giving it a lot of opportunity to make bad choices. Functions on columns makes it very hard for the cardinality estimator to figure out a good estimate and a good plan. So I'm just going to run this query with the cardinality estimator that was introduced in SQL Server 2014. Now I'm going to run it again, and this time I'm going to enable trace flag 9481 that reverts the cardinality estimator to the old version and has it it will force it to use the cardinality estimator from SQL 2012 and earlier. Then I will just execute the same query again, and we should get a different plan and a different result. Okay, so we've generated it with the other plan, and I'm going to go ahead and disable that trace flag. So now let's come back over to our query store, and let's take a look at our top resource consumers view. And right away we see, okay, we got this query here that's a big resource consumer, and we look and we click on the graph here to show it, and yep, sure enough, that's the query I was just running. And if we look over here at our graph for our plan guides, you can see there are two different plans that were generated. I can click on any one of them to switch between the plans. So and actually if we look down here, we can see the plans look oh great, SMS, don't crash on me. Okay, so let's get that going again. Perfect time for an SMS crash. There we go. Open our database back up. Put our queries back on this instance. Okay, so let's come back here to we were looking at the top resource consumers view. Let me close that. Okay, so we were looking at this. We can see, we have two plans here, two versions of the plan. They look very similar. If just by looking at it right away I'm not seeing like big differences between the two. Um, but if I wanted to, I can see this one used a lot less. Plan ID 31 used a lot less resources than the other. Oh, actually, it did use the same plan, but the difference. So in this case, the plan is the same because you can see there's one plan ID, 31 and 31, but you can see that they use different amounts of resources. Um, even though the plan was the same. So the other one reused the same plan, but it ran a lot longer. Um, so this identifies, if I wanted to force this plan, I've got it selected, I can click Force Plan, and it'll ask me, are you sure you want to force Plan 31 for Query 30? Say yes, and now any other iteration of this query that I run will use this plan. And you can see on here it's got a little check mark on it now indicating that it's forced. So it's very easy to tell. If you had a bunch of dots on here with a bunch of different plans, it would be very easy to tell that which of the plans was the forced one. And I can just click on it, and then if I decide I want to unforce that plan, I can just click unforce. It'll ask for confirmation, and I can unforce that plan. So this really gives me a great way to proactively, I can proactively identify these poor performing queries or queries that have inconsistent performance just by coming in here. This view, as we can see, it sorts it by the top resource consumers. So you say, in this case, we looked at the one that used the most resources, and we can see all the different iterations of it that it has saved. So it's it gives us a very proactive way to look at the data. We can come in here and we can see, okay, exactly what time these queries ran too. So if, like I said, somebody says, oh, it ran really slow at 2 a.m. And I could, my coming in here, my graph would be different time spans, and I would look at the 2 a.m., find the iteration of that. I could click on that dot for the one that ran at 2 a.m. I could see what the plan was. I could see how much resources it used, and it could really give me a ton of detail just from using the GUI. Other views is there are different ways to track queries in Query Store. The way I set it up, and the default method is when I enable Query Store, it will just track all queries that I'm executing. But you could also tell it to only track specific queries. So if we were to come back in here to the Properties tab, go to the Query Store, we can see that one of the options in here where was that option? Query Store Capture Mode. By default, it captures all of them, and you can set it to auto, and it can instead of capturing all queries, it can capture queries based on resource consumption. And so that way, if you only want to know about the ones that are using a fair amount of resources, you can set the capture mode to auto, and it'll only capture the ones that it feels needs to that exceeds some threshold. You can also, if you set it to none, by default it won't capture anything. However, you can then tell it to track certain queries. Now there are system procedures you can run, and you can tell it to, okay, I only want to track specific queries. So if I knew this one was bad, particularly troublesome query, I could track just this query, and if I'm tracking just that query, I could use this view for tracked queries, and it will only show me information about the queries that I'm specifically telling it to track this query. Currently, I'm not currently tracking any queries, so I'm not going to see any view in any information in there right away, but that gives you another way you can track. You don't have to, so you can control the amount of work that your query store does. Um, the in my experience so far, the overhead of query store has been fairly low, but if you do see that it's causing a significant amount of overhead, you may want to change that operating mode to auto, or maybe change it to off if you're only interested in specific queries. And of course, there's also the overall resource consumers, which it'll show you how much, what the overall resource usage is, which on my laptop that's not much right now. Regress queries. This will show you queries that where the performance is goes from being good to being bad. So it'll show you queries that the performance is changing drastically on. But we're not limited to just what is in those views. So they do give us some views out of the box, but there's a lot more data in that database other than just what's in those views. And I accidentally just closed that query window, so let me open that up again. I'm going to look at, I've written already a few queries for finding that information out. So for example, one of the queries that I may use is I say, okay, what's my 10 queries that had the longest execution time in the last day? So this is tracking all the time that these executions occur. So I can do a lot of things to say to limit it to only the last day or the last hour or whatever time frame I want. Now, one thing to bear in mind is these execution times in the query store. Like for example, in this query store, we're looking at the last execution time from the new system view sys.querystore runtime stats. So that's actual, it's capturing actual runtime stats for me. To see runtime stats prior to SQL 2016, I have to actually get the query and run it myself to see what those runtime stats are. This is actually capturing runtime stats for me. Um, but these date time fields that are in the query store DMVs are stored in UTC time. So when you query this, you need to understand that these dates are UTC. So to see them in your local time, so for example, I want to see 2 a.m. my time, I'm going to have to convert the time from UTC to my local time to be able to identify the correct range. So that's what I'm doing in these queries here. I'm saying where the last execution time is 24 hours from, and note I'm using get UTC date instead of get date because it's in UTC time. And then for the display, I'm actually saying, okay, calculate the difference between get date and get UTC date in minutes, and then subtract that number of minutes from that time to display it in my local time. So if I just run this query, and it'll give me the top 10 queries with the highest longest execution time, and we can see, it shows us what the average duration is. I've got this SQL text right here. Obviously, my two with the longest are the two versions of that query that I ran, and you can see what the difference between those durations are. And you can see the query ID, the ID for the query text, and the plan ID, and the last execution time. If I wanted to, another column I could very easily add to this query. In the query store, I am joining to the system view query store plan, so it does capture those cached query plans for you as well. So if I wanted to, I could just add the query plan here, and it would also give me that query plan as well in the output. Uh, um, so it gives me the XML. It's actually an invarchar format, so it's not going to, so I can't just click on it and view the plan at this point. So I can change p.query plan and cast it as XML. Now I have one thing I've run into with doing this, and is sometimes there are limits to the size of the query plan. It's limited to 127 nodes, and I've actually been running into this limit on a production system where I've been testing this quite a bit. No problem here today. These all converted fine, but once I've converted it to XML, I can just then click on the XML and it'll open up the graphical plan for me, and I can very easily look at that plan. Close that out. So, and I just learned, and I just discovered this past week with the failures casting that as XML. So instead, I could use try convert, um, and convert it to XML. And this is a much safer way. And this is new T-SQL that was introduced in it's already in current SQL Server, but it was introduced not too long ago. And the way this works is it will attempt to convert it to that format, and if it can, it'll do it. If for some reason there's some problem and it's not able to convert into that format, it'll return null for that value rather than throwing an error. So in this case, I would use try convert on these because I have discovered that it will fail on converting that to XML a good amount of time. So let's take a look at some of the other queries that I've written. The next query is top 10 queries with most I/O consumption. So let's say we're having a lot of I/O contention, and I want to see, okay, which queries are causing my I/O contention. And so this one, I'm also looking at just the last 24 hours. So I'm doing it where it's with the start time of the query in the sys.query store runtime stats interval, where the start time is greater than the last 24 hours ago. So you say, okay, here's my top I/O consuming queries, and you know, this is my laptop where I do demos, so I don't actually have a lot of I/O intensive queries running on here. I just enabled Query Store like 20 minutes ago, so I don't have a lot of information in here yet. But if this was a production system, I would be able to see, you know, what's the average I/O that this query is doing. Gives me the text and the query ID and plan ID and the runtime stats ID, so I can look up additional information if I choose to. The start and end time for the tracking interval. It tells me what the average row count is and the number of times it's been executed. So, you know, I can see, you know, on average what's the amount of I/O it's done. I can say, okay, and it's been executed this many times, so if I multiply the number of executions times the average I/O, it'll show me what the total I/O was. So the lot, and I can sort it by, okay, what's getting the most rows, so I can figure out which developer is not using where clauses on their queries and is just returning all the rows from the table, and I can go yell at them for doing that. And the next query I've written is queries where duration increased by more than double in the last 48 hours. So what I'm doing with this one is I'm actually doing some joining multiple times to the same tables to get multiple iterations of the same query, and saying, well, the execution time of the first one was greater than 48 hours ago, and that the execution time of the next one was greater than that, and that the plan IDs are different, and that the average duration is greater than double what the average duration of the first one was. So I'm saying, okay, whether the query ran twice as long or longer than an earlier execution of it within the last 48 hours, give me all that information. Again, this is just my demo laptop, so let's see if we got any information in there. In this particular case, we don't. I'm just working on my demo laptop. Sample query I ran didn't run more than twice as long as the first one. If it had, that one would show up in here. On a production system, and I've run these on a test production system where we have processes running against them, I actually do return a lot of information there and it's surprising, a lot of these things that I'm seeing are happening on these production systems and nobody's even noticing. So I'm finding a lot of these potential issues very proactively before developers or end users or anybody notices that there's an issue. So it's allowing me to identify these potential problems well before users are ever complaining about them. Ideally, it would be great for me to be able to find the things that the end users will eventually complain about and fix them before they do, so that I never have to hear from them. And that's the dream. And my last query I'm going to show you here is queries with more than one plan in the last hour. And if that query I ran had generated a different plan the second time instead of using the same plan, it would show up here. So I'm just saying, okay, where it's the last compile start time from sys.queryStorePlan is greater than an hour ago, and I'm grouping by the query ID, so this it's grouping by the query itself, and then it has a count distinct plan ID greater than 1. So same query, more than one plan ID within the last hour. And so I just query for that, see if we get any hits here. We do get one hit here. We can see the query ID 28 has had 2 plans, and we can see what the SQL text here is, the compile time, the execution time. So let's go back to the view real quick and see if we can find query ID 28 on here. So let's see, track queries asks for a query ID. Let's see if we can see if it'll find query 28 for us. So we got that query. We can see, wow, look at here. We took that query ID from the plan here, entered it into the track queries, and I can see, it's got 2 plans here. It shows you plan 29, plan 58. So there's 58. That's the higher consumer. Plan 29. Actually, you can see one of the things I noticed right away is with plan 29 right here, I've got a stream aggregate. With plan 58, I've got a hatch match. So it is generating a different shaped plan. And SSMS is crashing again. My apologies for the repeated SSMS crash. Let me come back in here to my view. So I was looking at track queries, query ID of 28. We can see that it's given us different plans here. Plan ID 29 is a much is appears to be a much better plan. So if I wanted to force this query to always use that plan, I could do that. And I know that next time this particular query runs, it's going to use the same plan, and I would expect for it to get the same, to perform better. Um, I can come back in here later and look at this same query ID again, and and I'll see more iterations of this as it is run, and then I can say, oh, okay, so that forced plan is actually, I can easily see just from looking at this visual here, you can look at the graph, say, okay, the forced plan is either it is performing well consistently or it's not. If it's not, I may choose at that point to unforce it. But so after forcing it, I'll probably come in here like maybe the next day, look at that to see if this is actually performing well. Now, another option we have in here, so we can see from this view, we have the option to use the other tool that I wanted to talk about, the plan compare tool. So from right here, I have compare plans. Um, so this does require that you have two plans. So in this case, what I can do, since this has two plans, I can select, let's see. So I need to use shift click. So I have one selected here, hold down shift and click on the other, and I now have both of these plans selected, and I can click the compare plans, and it opens these two plans right up into the plan compare tool for me. So I'm actually going to slide this over so we can get a better look. And so and actually this is a newer version of SSMS than what the screenshots were taken with. So the display does look a little different than what we showed on the screen. But as you can see here, I just clicked on one of the nodes and it synced up both copies of the plan so that it highlights those two nodes. And I've got over here, I've got the plan properties of both nodes. And one of the improvements they've made to this with more recent versions of SSMS, instead of you just having to know that the left one is the top one and the right one is bottom, it says top plan and bottom plan. And we can see right away, and we can just do a compare to look for things that are different. For example, we can see here estimated number of executions is 2.111, and here it's 1.037037. We can see that the estimated cost is slightly different. The estimated rebinds is slightly different. So we can see that there are some things that are different here. Now, in many cases, you know, these won't line up very nicely, and it can be hard to find specific things. So I'd say, now one thing I noticed before was, you know, where we had the hash match, this hash match node in the top plan, it had a stream aggregate node. So rather than having to try to search, okay, what matches up to that, I can, you know, click there and it says, okay, it's doing the stream aggregate instead of the hash match aggregate. So it can identify those different nodes for you to make sure that you're comparing apples to apples. And it doesn't matter if I click on the bottom or the top, it'll sync them up for me so that I can always be comparing apples to apples. Very great tool for really identifying what's different in the plans and trying to figure out, and then once I know what's different, I can try to figure out why they're different. But I don't have to use this from Query Store. And actually, this tool I can use with old versions of SQL Server. So the Plan Compare tool is a tool within SQL Server Management Studio, and so you don't need to connect to SQL 2016 to be able to use that. You can connect to older versions of SQL Server. You can compare plans that you've saved from older versions of SQL Server. You can and or any or um, so yeah, so it doesn't have to be just SQL Server 2016. I could also, rather than using this from the Query Store GUI, if I wanted to, let's say I ran a query and I said, okay, include actual execution plan. Anytime I'm looking at an execution plan, I have the option to compare that plan to another plan. So in this case, I can just right-click in an open white space area, and one of the options I have in here is compare show plan. In this case, I don't have uh, two plans that are in SMS to point it to. So in this case, when I'm right-clicking on the plan I have open and saying compare show plan, it's going to ask me to direct it to point it to where the plan is in the file system. So what I would do is if I was running two different versions of the same query, I would run the first version, right-click on the plan, and so I can just right-click and say save execution plan is, save that somewhere um, in the file system, then do the second one, and once I have the second one up, I would then do the compare show plan and tell it to load the one that I had saved earlier. Now for this example, I actually have a couple of query plans that I've already saved. So in this case, I'm going to compare an actual query plan to a cached query plan. So I'm going to go ahead and open up the actual plan in SQL Server Management Studio. Just drop it right up there. And we see now, normally, this is the view we're used to when looking at query plans. We've got a query plan, and we can click on nodes, and we can dive into the properties of those nodes over on the right here. So I'm going to compare this to the other plan, so I'm going to right-click in the open white space area and say compare show plan. And now I'm going to point it to where I have this stored, 24 hours have passed, my session, query plans. And so I see my query plans here. The actual plan is the one I already have open, so I'm going to open query plan 2, and it loads that up for me. And when I was looking at the plans from the query store, it had the basically the body of the query was in one big highlighted thing, so it was hard to see the color coding. But here we can see that because that doesn't have that highlighting, we can see the color coding in here. We can easily see what nodes match up to each other. So we can say, okay, we can see, okay, we got pink and green and all these different colors. And here's one. So we got this sort of a pastel green color here. I don't see that color in the top screen, so I'm going to click on that. And again, it syncs up that node. There's that, that pastel green color node. And again, it syncs those up for us. And it does give us down here, some information about what the different lines and styles of lines around the boxes means. But we can see, we're looking at this green one here, we can see this green long dotted line means clustered index scan is this one. We can see this orange one, and we can sync up those plans by using this compare operation. So we can look through here and say, okay, what's something that we want to look at? Okay, clustered index scans, maybe that's something we can optimize out. So let's click on the clustered index scan here to switch to that node, and it syncs both of these up there onto that specific node and say, okay, so, and then I can start diving into why isn't this using another index on that table that I think it should be. And actually here, this is actually a good one to look at the properties of, because we can see here the cost for the top plan is 0%. So it says, okay, clustered index scan, this is a very cheap cost, so I'm going to do a scan. So it may have said, okay, clustered index scan in this case was cheaper than using an index seek if it had to do key lookups in addition to doing the non-clustered index seek. But in this one, it's not so cheap. So we can see that there is a difference between these two as far as cost. And you'll notice that because I'm comparing an actual plan to a cash plan, that the actual plan has more information. So with the actual plan, I can see the actual number of rows here. This one actually did 3 rows. Over here, the cash plan, I don't have that actual information because it's not the actual plan, it's the cash plan. But I can still compare, like the estimated CPU cost was 0.0001603 for the top plan, and estimated CPU cost was a little bit different, lower for the cash plan. So you can identify where these differences are in the estimations, and if it is an actual plan, you can as you could before, you can compare what the actual results were. And so it really gives us, a lot of, really makes it very simple for us to find plans that identify those nodes that are where it's doing certain operations and trying to figure out why it's doing those. Now if I click on a node that isn't identified as being similar between the two, it won't do a sync because it doesn't know what exactly matches to it up here. So because it wasn't able to identify those nodes, because if we look here in the top one, I've got a bunch of hash matches and I'm not seeing the merge joins. So in this case, there isn't a merge join up here for me to match it to. So you're not going to be able, when the plans are different, not everything's going to match up, but you will be able, for the ones that it is able to match up, you will be able to do some really great comparisons of those. So very valuable tools. So let's come back to our slide deck here. So that was our demo for these two tools. They give us these great tools for performance tuning in SQL 2016, the query store, the plan compare tools. But in my opinion, I think they're more than just tools for performance tuning. I think it's a whole new paradigm for performance tuning. And I've provided you some links in the slide deck for some additional resources where you can take a look at in deeper detail these particular tools. And so I'd like to open up for any questions we've received, Elizabeth.
Hi, yes, we do have a few questions. The first one is, are these features Enterprise Edition only?
Great question. It's one of the, and there was actually a couple of MVPs that had a bet going about whether the query store would be available in standard edition or not. And Query Plan Tool is an SSMS tool, so it doesn't matter what version or edition you're using. You can use that with even old versions, any edition of SQL Server. Query Store, I'm very happy to say, is available in all editions of SQL Server, so neither of these tools are Enterprise Edition only.
Okay. The next question is, I see that the tables are sys.query_store_query_text and sys.query_store_query, and not sys.dm_**, which leads to the question that the query store is persistent between instant restarts, unlike the DMVs.
Yes, you are absolutely correct. These are catalog views, and in fact, I can even completely disable Query Store, and then if I go back in and re-enable it, all that data that was collected is still there. So yes, it is persistent, and it isn't just since last restart. It is persistent data stored in underlying tables.
Okay, and I think the last one we'll have time for is, would it be possible to get copies of your query store scripts?
Yes, and actually I have. Um, I recently at SQL Saturday Rochester, just a couple of weeks ago, I presented on this very same presentation at their SQL Saturday. I'll post this on my website as well, SQLSoldier.com. But you can also, right now, you can go to the SQL Saturday website, pull up the event SQL Saturday Rochester that just happened um, a couple weeks ago, and download them from there as well. They're already uploaded to the SQL Saturday website there. But I'll post them on my blog as well later today on SQLSoldier.com.
Okay, great. So that's all we have time for. Robert, if you could go to the next slide. So make sure to stay tuned for our next session, Perfect Fits for Azure SQL Database Migrations with Grant Fritchie. And next slide. Thank you for attending, everyone. Follow us on Twitter at pass24HOP and share your thoughts with us with the hashtag 24HOP. Thank you, Robert, for a fantastic session, and thank you all for attending.
Thanks, everybody.